Hello students, today we will discuss the second topic of engineering drawing, that is dimensioning. Since in engineering drawing you have to draw the figures, the measurements of the objects have to be represented on the figures. What are the measurements like length, height, width? All these measurements we represent along with the figures. What is dimensioning? Dimensioning is defined as an art of representing the measurements of any object on its figure. Okay, in this video we will discuss the various types of dimensioning and various systems of dimensioning. So let us move to the board. Dimensioning is an art of representing the measurements of an object on its figure, right? So the first thing that we'll be learning here is the classification. Classification of dimensioning. So basically dimensioning is classified into two types. First is size dimensioning, and second is location dimensioning. So the figures, for this you need not draw, but you need to understand the concept. Right? So size dimensioning and location dimensioning. So the first one, as the name indicates, size dimensioning means the type of dimensioning which tells us the size of any object. Okay, so for example, let us say I have this object, right? This is a rectangular plate and there is a hole in between. Okay, let us suppose this is the center and you draw a circle over here like this, right? Now let us say this is equal to 50 mm and this is equal to 70 mm. Right? And the diameter for the circle it is represented by phi. Let it be equal to 20 mm. Okay, so if you look at this figure, it basically tells you the size of this object, that this side is equal to 50 mm, this side is equal to 70 mm, and the circle diameter of the circle is equal to 20 mm, right? So this is known as size dimensioning. The next is, so I'll not change the figure. Next is location dimensioning, second one. Location dimensioning. So let us not change the figure. The same figure I'll be keeping again for this also. So here, if you see, in this rectangular plate, again I have the center line. This is the center circle or central hole, right? Now, if I represent it like this, that this is 25, okay, and this is 35, right? Now, what does it mean? It means that this figure actually indicates the location of center of the circle, because the center of the circle is located vertically 25 mm from this corner, okay, and horizontally 35 mm from this corner. So this type of dimensioning, it is known as location dimensioning, right? So next is system of dimensioning, systems of dimensioning. Systems of dimensioning. So under the dimensioning, there are two systems. First system of dimensioning, it is aligned system. Aligned system of dimensioning. Okay, let us just draw the figure for this aligned system. The second one is unidirectional system, so that we will do afterwards. So let us see the figure. What is the figure? So you need to draw a square of 90 by 90. Right? So then in this you have a center line passing through the center. So this figure you need to draw, and let us draw a center line over here also. Let us say this is the center, and you draw a circle. Let this circle be let the circle be equal to the diameter of 30 mm. Let it be equal to 30 mm. Right? So after this, you have two more circles. Let us first of all draw the center lines. It is like this. Then total it is equal to 90 mm. Draw a dimension line. This is equal to 90. And from here also you have the center line. This is equal to 45. Right, so then you have 30 mm on both the sides. And then you have 20 mm also. So first circle here, this is second circle, and this is the third circle. Similarly, this is again the circle you have to draw, and this circle also you have to draw. So these 5 circles are of 5 circles, phi 10, right? So these are 5 circles, phi 10, and this circle, let it be equal to 30 mm. So you dimension it outside the figure. Phi 30, let it be. Right? So then let us dimension the other quantities also. So this is equal to 25. Sorry, this is equal to 20. This is also equal to 20. This is equal to 30. This is, and this is also equal to 30. Then this is equal to 10. And this is equal to 20. And this is equal to 45. Right, so this is aligned system. Now what is the meaning of aligned system? So all your dimensions that you are writing here, all these dimensions are aligned to the dimension line. Okay, all these dimensions are aligned. So what is the meaning of aligned? So if you draw the dimension like this, so the direction of this measurement that you are writing, this also changes. Let us say if it is again inclined, so it will be again changing. It will be like this. So this is the meaning of aligned system of dimensioning. Right? I suppose this is clear. The next is the unidirectional system of dimension. Unidirectional. Unidirectional. So as the name indicates, unidirectional means in a single direction. Okay, the direction of these measurements that you are writing, it is not changing now. Okay, like it was changing here with the inclination of these dimension lines. So this is not changing now, right? So what will be the change then? So this here, it will become like this. This is 30. This is also 30. This is 90. Again, this is 45. Now these all have been written in a single direction and between the lines. It is not written above the line, it is written between the lines, dimension lines, and in a single direction. So here, if you see this, what will this be written as? It will be written as like this in a single direction. This also, it will be written like this in a single direction. So this is the unidirectional system of dimensioning. So normally in a figure, either we follow a line system of dimensioning or we follow unidirectional system of dimensioning. So only single system of dimensioning we will be following, right? So this was all about the systems of dimensioning. Next is the different types of dimensioning. First is parallel dimensioning. Parallel dimensioning. So parallel dimensioning, it means you have an object, okay, in which the dimensionings are parallel to each other. The dimension lines are parallel to each other. So how we will draw this? Just see. So just draw a center line after this. And then you have different circles. So you have to draw 6 circles here. Right? So these are the center lines. So here this is known as datum surface. Datum surface. Okay, so basically in parallel dimensioning, all the dimensions are measured from a single datum surface. This is known as datum surface. So this first one, first dimension, it is equal to 20 mm. This is 20. This is equal to 40. This is equal to 65. Then next it is equal to 75. Then next it is equal to 85. And next it is equal to 95. Sorry, 90. And last one, it is equal to, total it is equal to 105. Right, so here you can see all the dimensions are parallel to each other. All the dimension lines are parallel to each other. So this is known as parallel dimensioning, right? So now if you want to draw the chain dimension, there is an option of chain dimensioning also. Chain dimension. Now what is chain dimensioning? In chain dimensioning, like here you had all the dimensions parallel to each other. So in chain dimensioning, you will have all the dimensions which are in a line, which form a chain. So I'm converting this same figure into chain dimensioning now. So it would be easy for you to understand. So this is equal to 20. Then next it is equal to 25. Next it is equal to 10. Again 10. Again 10. And this last one is equal to 15. So this is known as chain dimensioning, in which your figure forms a chain. Dimensionings of the figure form a chain, so it is known as chain dimensioning. I hope the concept of dimensioning, the systems of dimensioning and types of dimensioning are clear to you. Let us meet in the next video with some other topic. Thank you so much.